Hello students, so we already studied about Kirchhoff's laws. Today we are going to study about Wheatstone's principle.
Wheatstone's principle or Wheatstone's bridge. Wheatstone's bridge consists of four resistors which are P, Q, R and S. It consists of four resistors P, Q, R and S, in which we know the value of P, Q and R, and S is an unknown resistance. Unknown. So here we know the value of P, Q and R, and the value of S is unknown. So according to Wheatstone's principle, we have to find out the value of unknown resistance. So today we are going to find out the value of unknown resistance using Wheatstone's bridge. So this is the experimental arrangement of Wheatstone's bridge. It consists of four resistors. This resistor is P, we can name it as P. This one is Q, this one is R, and this one is S, in which the value of three of the resistors are known and one is unknown. Here P, Q, R are known resistors and S is unknown resistor. Like as shown in the figure, there is an external battery which we are connected to the bridge so that an amount of current will pass through the bridge. Suppose that I is the current that is passing through the bridge when we connected it to an external battery. The values and directions of current through various arms can be determined using Kirchhoff's second law that we already studied in the previous episode. Here, when the current reaches the point A, it will splits into two and an amount of I1 current is passing through resistor P and I2 amount of current will pass through the resistor capital R. And when I1 reaches B, it will splits into two and I3 amount of current is passed through the resistor Q and an IG current will pass through the sensitive galvanometer that we connected across the points B and D. And at the point D, the current I2 and current IG will combine together and it forms a current of I4 and it passes through the resistor S. So according to Kirchhoff's first law, we know that the sum of the current entering the junction should leave the junction. So here the amount of current that entered the junction is I. So amount of current that leaving the junction should be also I. So here current entered is also I and the current that is leaving is also I. Now we are going to apply Kirchhoff's second law in each of the loops in this bridge. So first we are going to consider the closed loop A, B, D, A. You can see the loop. This is A, B, D and A. So we are going to apply Kirchhoff's second law on this loop A, B, D. So here the first current is I1 and the resistor is P plus the current through the galvanometer is IG and the resistance there is capital G plus third current is I2 and the resistor is capital R. But here we know that the current I2 is in opposite direction of that of I1 and IG. So we have to give a negative sign for I2. So that is equal to 0. 0 because there is no source of EMF in that closed loop. So we can write the equation as I1P plus IGG minus I2R is equal to 0. This is equation number 1. Now we are going to apply the Kirchhoff's second law on the closed loop BCDB. Now we are going to consider the closed loop BCDB. So in this loop, the first current is I3 and the resistor with that current is Q, plus I4 S plus IG, G is equal to 0. But here we know that the current I4 and current IG is in opposite direction with current I3. So we have to give negative signs for I4 and IG. So we get the equation as I3Q minus I4S minus IGG is equal to 0. This is equation number 2. So we applied Kirchhoff's second rule on both of the closed loops AB, DA and BC, DB. Now we are going to adjust the value of the resistors P, Q and R in such a way that the current through galvanometer, that means IG, the current through the galvanometer, become 0. Then we can say that the Wheatstone bridge is balanced. This condition is known as the balanced condition of Wheatstone's bridge. So for balance the Wheatstone's bridge, we are going to adjust the value of P, Q and R so that the value of IG becomes 0. That condition is known as balanced condition of Wheatstone's bridge. When IG becomes 0, I1 will be equal to I3. That when IG becomes 0, so the current I1 will pass through the resistor Q. That means I1 and I3 become equal. So we can say that when IG is equal to 0, I1 is equal to I3. Likewise, I2 will be equal to I4. When IG becomes 0, I2 will be equal to I4. Then equation number 1 becomes I1P plus 0. That means IG becomes 0. So the total term becomes 0. So I1P plus 0 minus I2R is equal to 0. Or we can write I1P minus I2R is equal to 0. Then I1P equals to I2R, equation number 3. So when IG becomes 0, equation 2 becomes I3Q minus I4S minus 0. That when IG becomes 0, the total term becomes 0. So this is equal to 0. We can write I3Q is equal to I4S. That is equation number 4. So here in equation number 3, we are going to apply the condition I2 is equal to I4. When I2 becomes I4, equation number 3 becomes I1P is equal to I4R. Equation number 5. And here in equation number 2, when we apply I1 is equal to I3, then we get I1 Q is equal to I4S. That means instead of I3, so here in this equation, instead of I1, we applied I3 because I1 is equal to I3. So our equation becomes I1 Q is equal to I4S, which is equation number 6. So now we are going to divide equation number 5 and 6. So equation number 5 divided by 6, and we get I1P by I1Q is equal to I4R by I4S. So here I1 and I1 cancels each other, I4 and I4 cancel each other, then we get P by Q is equal to R by S. So from Wheatstone's bridge we get P by Q is equal to R by S. So here we know the value of P, Q and R. These three resistors are non-resistors and S is the unknown resistance. So from this equation we can easily find out the value of S using the equation S is equal to QR by P. So this is known as Wheatstone's principle. This is Wheatstone's principle. So according to Wheatstone's principle, when the bridge is balanced, the ratio of resistances in the adjacent arms of the Wheatstone's bridge will be equal. So according to Wheatstone's principle, when the bridge is balanced, the ratio of resistance in the adjacent arms of the Wheatstone's bridge will be equal. If the position of galvanometer and cell are interchanged, there will not be a change in the Wheatstone's principle. If the position of galvanometer and cell are interchanged, there will not be a change in the Wheatstone's principle. If we rearrange cell and galvanometer, then also we get the Wheatstone's principle's equation as S is equal to QR by P itself.
So today we studied about Wheatstone's principle. Wheatstone's principle is used to find out the unknown resistance on the bridge. So here the equation for finding the unknown resistance is S is equal to QR by P. Hope you understood. Thank you.